Now we'll move on to the transmitter architectures. So transmitter, it performs the operation of modulation, up conversion, and power amplification. See, remember, all transmitters use high power amplifiers. All receivers use low noise amplifiers. The modulation, it is done for long distance transmission. Up conversion, for using an antenna for wireless mode of communication, and power amplification for the signal to travel a large range to cover a large distance. So in today's architecture, GSM uses GMSK modulation, Gaussian minimum shift keying technique, and that is going to have the signal is going to follow this one. In Gaussian minimum shift keying technique, the signal is going to be A cos omega ct cos phi minus A sin omega ct sin phi, and phi is going to be this integral. So phi is going to be the actual signal with the multiplied by the baseband processor. Okay, cos phi and sin phi are produced from the baseband signal in phase and quadrature phase. So we have seen for the pulse shaping, each rectangular pulse must be transformed into a smooth pulse. You cannot send rectangular pulse as it is. It has to be transmitted in the form of a Gaussian pulse. So pulse shaping also plays a very, very important role in transmitter architecture. So the input pulse will generate a sequence of addresses, and when you're going to process everything in digital domain, then you have to properly convert the analog signal into the digital signal. Okay, and for what pulse, what shape I'm going to use, everything has to be mapped in the memory. Now, that is what is given here. So you can see here, for this baseband signal, it will generate an address. It will go to the IROM, it will go to the ROM and pick out the I and Q components, convert it into a DAC, LPF, multiply by the corresponding LOs, quadrature LOs, and you will be getting back your modulated signal. This modulated signal will be having Gaussian mean shift keying pulse shape. And Gaussian signal, it is going to be a bell-shaped curve. It is going to be a bell-shaped curve. So zeros and ones will pass through this circuit to generate the pulse shaping circuit. And pulse shaping circuits are required to minimize inter-symbol interference. So when at the receiver, when you transmit a larger number of pulses, the pulses will start overlapping. So to prevent overlapping, we do this proper pulse shaping so that it overcomes the effect of inter-symbol interference. ISI, you call it as ISI in short form.